All right, there's a small trick to doing this one when we're fighting a negative x robot. So we have what kind of looks like a standard problem, but there's a subtle difference here. This time the negative is on the x box. So we have 3 minus x is equal to negative 7. Now, initially, people would want to say they come in and they want to punch that 3 on the other side because that's what's causing the x to not be alone. Punch it over, turn that positive 3 into a negative 3, and what you're going to get is maybe negative 7 minus 3 on the right hand side. And what you'll do is, okay, well, negative 7 plus negative 3 is negative 10. And let me warn you, this is absolutely the wrong way to do this problem. Because x does not equal to negative 10. You didn't isolate x all by itself. You isolated negative x all by itself. Here's another approach to doing the same problem. Here's the initial problem. 3 minus x is equal to negative 7. And what I'm going to do is I'm going to kick that x over to the other side, making it a positive x. And that is what we always try to solve for, positive x. I'm going to move that negative 7 over to the other side, making it a positive 7. And in the end, I have 3 plus 7. And so I know what that equals to. Let me show you what it looks like in symbols. 3 minus x is equal to negative 7. I move the x over to the other side, so I change it from a negative x to a positive x. I'm going to move this negative 7 over to the left side, changing it from a negative 7 to a positive 7. And then 3 plus 7, well, that's equal to 10. Done. Again, we always check our work. I think that x is equal to 10. Let's check. We have 3 minus x is equal to negative 7. That's the original problem. And we think that x is equal to 10. We write down the original problem, 3 minus x, but instead of writing an x, we put a 10. So 3 minus 10 is equal to 7. Well, 3 minus 10 is actually, 3 minus 10 is equal to negative 7. And actually, 3 minus 10 is equal to negative 7. So negative 7 equals negative 7. This checks out. This is true. So here's the problem we have. Negative 5 minus x equals negative 5. There's a lot of negatives here, but let's see what we can do. I'm going to take that x, and I'm going to deal with the negative x first. So I'm going to kick that guy over to the right-hand side, making it a positive x. All right, that's pretty interesting. Then I need to get rid of that negative 5. So what I did was I made it a positive x, which is what we need to make sure the x is if we want to try to isolate x all by itself. We can't solve a problem and have it equal to negative x. We need to have it equal to positive x. The thing that's guarding that negative or that positive x from being all by itself on the right hand side is the negative 5. So in order to get rid of that, I'm going to kick that guy over to the left hand side. And when it moves over the equal sign, it turns into a positive 5. There we go. All right, let's look at this problem using symbols. Negative 5 minus x equals negative 5. Move the x over. Move the 5 over. Negative 5 plus 5 is actually equal to 0. And we're done. Well, we're not done, because what we need to do is always check our work. Here's the original problem, and I have x is equal to 0. That's what I think the answer is. I'm going to plug in x equal to 0 right into the equation, and I have negative 5 minus 0 equals negative 5. Negative 5 equals negative 5. We are good to go and done with this problem. Let's try this example. So I have 0 equals 49 minus x. I think what I'm going to do is I'm going to kick that x over to the other side. From the right-hand side, since it's a negative x, I'm going to move it over to the left-hand side, making it a positive x. There we go. And that's pretty much it. I'll show it to you in symbols. 0 equals 49 minus x. That's the original problem. I'm going to move the x over to the other side. And I did 2 steps here at one time. 0 plus x is still x. So x is equal to 49. We're done. Well, we're not done. We need to always check our work. If we think that x is equal to 49, we better plug in x equals 49 and see if it works. So we have 0 is equal to 49 minus 49. Well, that's definitely true. I love teaching you a little bit more about how this algebra stuff works. And what's really important here is that when you solve for x, it needs to be x plus or positive x. It can't be negative x is equal to blah, 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 because that isn't solving for x. That's not isolating x all by itself. So you'll need to adjust that negative x to move it to the right or to the left in order to get it to be positive x, because that's what you want to isolate. That's what you want to solve for.